And we are beginning the second section in chapter 4, 4.2. Go ahead and copy that title down in your notes. Solving quadratic equations by graphing. Solving quadratic equations by graphing. Of course, put the date and the day. Write that down as the title. And here are the first part of the notes that you guys need to jot down in your notebooks. There's really not that many notes. This is what's important here. The x-intercepts of a parabola are the solutions to a quadratic equation. Okay? The x-intercepts of a parabola are the solutions to a quadratic equation. Now, if you don't know what that means, remember, we've been graphing parabolas. Now, let's say that you had this type of parabola right here. Let's say you graphed the equation using all that fun stuff of finding the vertex, doing x equals negative b over 2a, plugging in that value to find the y value. Then you use the xy table or the pattern 1, 1, 2, 4, 3, 9 to actually come up with coordinates and graph it. Now, let's say you did graph it. Let's say that this crossed at the x-intercept of 1 and the x-intercept of like negative 5, right? Then those answers would be 1 and negative 5. What the above statement is saying is that the x-intercepts of a parabola are the solutions. They're the answers to a quadratic equation. So let's check this out. This is very, very important. Answers, let me actually make this smaller, Answers, solutions, x-intercepts, roots, all of these guys mean the same thing. They all mean the same thing, okay? So if I give you a quadratic equation and I tell you find the answers, you know what to do, you solve it, right? Or if I tell you find the solutions, the same thing, you solve it. Find the x-intercepts, you solve it. Find the roots, you solve it, right? So I need you guys to memorize that all of these words, answers, solutions, x-intercepts, roots, they all mean the same thing. It's really to find the answers to the quadratic equation. And how do you find answers? Well, there's different ways of doing it. Today we're going to find these answers by graphing. But before we get into graphing, let's go way back in time. I'm talking about the second week of school, I believe, where we were solving quadratic equations, not by graphing, but by using factoring. So everybody please jot down this quadratic equation. X squared minus 2x minus 3 equals 0. Now, back in the second week of school, in Unit 0, we actually solved equations and we solved quadratic equations by factoring, right? I don't know if you guys remember that, but hopefully this looks familiar, where you have x squared plus something x plus something. It's in standard form, which is the type that we've been graphing these days. But back then, I said, try to factor it. And factoring is really like a reverse distributive property. So all you got to do is think of the c value and think what times what is the c value that if you combine together is the b value. Okay? Now, if you don't see it right off the bat, you could go ahead and make a list. How could you get negative 3? Well, negative 1 times 3. 2, no, that's it. That's the only possibility, negative 1 and 3. So if I added these guys together, does it give me negative 2? No. It gives me a positive 2, right? So I have the right pair of numbers, I just have the wrong signs. So that must mean that the negative 1 should be positive and the 3 should be a negative 3. So I hope you guys remember that you put an x right here and an x right there, and you simply plug in your positive 1 value and your negative 3 value, and you have factored. We did a reverse distributive property right there. Now, if I were to actually distribute x times x, I'd get x squared. X times negative 3, I'd get negative 3x. 1 times x, I'd get positive x. And the negative 3x and the positive x give me the middle value, negative 2x. Does this sound familiar? Yeah. Okay. So why do we factor? Because there's this thing called the zero product property that says when you have something times something and it gives you 0, then that first something could be 0, or the second something could be 0. So this is where, I hope you guys remember, where you factor, you split them, and then you solve. So you end up with an answer, x equals -1, that's one answer. And another answer, if you add 3 to both sides, would be x equals +3. So you get two answers. That was back in the second week of school when we focused in, hit factoring really hard. And we solved this quadratic equation by factoring. Now today, if you look at the notes up here, we're not solving quadratic equations by factoring, we're solving by graphing. So what does this really mean? This means that if I go back to the original, now let me not include the equal 0. Let me just do this, go back to the original. Let me pretend it's a function, y equals, or f of x equals, right? And if I, whoa. Okay, so I've deleted some work here, and once again, let me just move these answers to the side. Let's pretend that this were a quadratic equation, y equals x squared minus 2x minus 3. Now, what if I told you to graph it? What would we start with? Vertex, right? The vertex is a coordinate. How do you find the vertex? X equals -b over 2 times a. Okay, so the b value is -2. The a value is 1. So you really have a 2 over a 2, which means that your x value of your vertex is 1. Are you with me?
Yeah.
Okay, now what do I do from there?
Plug it in.
Plug it in. So if I take the 1, which is the x value, plug it in for the x, plug it in for the x, that'd be 1 squared, which is still 1. 2 times 1 is 2. 1 take away 2 is -1, and -1 minus 3 is -4. I hope everybody followed me right there. Yay?
Yeah.
Okay, now if I wanted to graph this thing, let me make some space here by moving this a little over to the side. Let me do a quick sketch here. So I would go to 1 and -4. Wow, that's going to be ugly. Let's try it. So if I go 1 and -4, it'll be down here. Oh, +1, -4, thank you. So +1, -4, it's going to be down here. And this a value is 1. So I could use the pattern 1 over 1 up, and then 2 over 4 up. Okay? So I would put a dot right here and right here. Okay? If you had a nice perfect graph, you would see that this coordinate is the coordinate -1, 0. Okay? And if we went with the same pattern in the other direction, it would be here and here, here and here. So this is really bad. I apologize. But the fact is that if I were to have graphed this perfectly on graph paper, my x-intercept values will be the values -1 for x and 3 for x. Okay, so the original notes that you guys jotted down say that your x-intercepts are your solutions, they are your answers. Remember all those list of words? The answers are the solutions, they're the x-intercepts, they're the roots. So today we're going to be solving these quadratic equations by graphing. So if you take this and graph it, you get a parabola, and wherever you see the x-intercept values, that's what your answers are. Those are your solutions, or your roots. Got it? Let's all take a look at the homework assignment. We just handed it out. Let's look at this side. It is a two-sided assignment. The answers are not in the back. The answers will be on Edmodo, though, so you can check your answers. But what we're looking at is the one that says 4.2 skills practice. Skills practice. Now, if you take a look at number 1, it says use a related graph of each equation to determine its solutions. Okay, so guess what? They already graphed it for you. So they give you a quadratic equation, and we need to solve this quadratic equation. Now, what I would do if I did not have the graph, I would factor and split and solve. So I would think, oh, x times x will give me an x squared. What times what is -3? That if I add together is +2. Well, that's a +3 and a -1 equals 0. And if I split them and solve, I'd get my two answers, x equals what? If I split them and solve, x equals what? -3. And also x equals what? 1. That's right, you get two answers. Now remember that list of words that I gave you on your notes just a couple of minutes ago. The answers are the solutions. They are the x-intercepts. They are the roots. So notice that you didn't have to do any of this work because this was already graphed for you, and you could clearly see where it crosses the x-axis. Where does it cross the x-axis? What is this value? It's 1, right? What is this value? It's -3. So you have the answers just by looking at the graph. So once again, what I did, I factored. You're not supposed to factor in this section, right? But now you have something times something equals 0. So because something times something equals 0, you could say x plus 3 could be 0. And also x minus 1 could be 0. So if you did solve the top one and go -3 minus 3, you'd get x equals -3. If you solve the bottom one, x plus 1 plus 1, x equals 1. So you get your two answers. The answers are the same as x-intercepts. There's the x-intercept of 1. There's the x-intercept of -3. You get it? Okay. So if it's graph for you, you're done. Check this out. What's the answer to this one without doing any math? The answer is x equals -3. You got it? It's important to note that sometimes with U-shaped curves, it could pass 1, 2, or it could just pass one time. It touches, right? So it is possible that it crosses twice. Crosses twice. It's also possible that it crosses or just touches it once. And it's also possible over here. What's my solution over here? No solution. That's right. So no solution. Why is there no solution? Because there is no x-intercepts. Remember, the x-intercepts are the same thing as solutions. So right there is no answer. You could use a symbol if you want, but there is no answer to this quadratic trinomial equation. You can't find an answer. It doesn't exist because answers are x-intercepts. Okay, guys, so let's jump to numbers 4 and 5. Since we don't have graphing calculators, but they want us to solve the answers and see if by graphing and see what the x-intercepts are. And notice it says if the exact root cannot be found. What does root mean? Answer. If the exact answer cannot be found, state between which roots, which answers they're located. Okay? So you would have to graph number 4 using x equals -b over 2a, finding the vertex, which is a coordinate. And if you do the math here, it's actually -6. Sorry. So that becomes +6 plus +6 over 2. That becomes +3 as the x value of your vertex. Then you plug it back in. Let me try to do this in my mind here. 3 squared is 9. Let me write that down. 6 times 3 is 18. So you have 9 minus 18 plus 5. 9 minus 18 is -9, and -9 plus 5 is -4. So when we plug in a +3, we get out a -4. That's the most important part of our parabola, the vertex. So if I do go out 1, 2, 3, 1, 2, 3, 4, I'll end up right there. Agree? Yeah. And of course, we have an axis of symmetry running right through that vertex. And we need more points, so what would I do? I'd go to an XY table, or we could use the pattern. Yes, hi. So instead of wasting more time plugging in values for x into the function, we might as well use the pattern 1, 1, 2, 4, 3, 9. So 1 over 1 up, that'll give you this coordinate. If I go 2 over 1, 2 from the vertex, 4 up, 1, 2, 3, 4, you'll be on the x-axis right there. And you could map it over to the other side. Map both coordinates over to the other side. And now you have your perfect parabola going right through those coordinates. Now, what are we trying to find here? We're trying to find the answers, the solutions, which are the x-intercepts. So we're talking about this value right here and this value right there. What is this value? So yeah, that's your answer. X equals 1. And the other one? X equals 5. So ladies and gentlemen, those are your two answers to the original equation, x squared